Did you know that in Ecuador last year we had power outages that lasted up to 14 hours a day? Hello and welcome to this presentation about the solution we developed to face this energy crisis in Ecuador.
During our investigation on Ecuador's recent energy crisis, we identified a major problem. Solutions of building new energy sources cannot be executed because of major obstacles like budget, proper investment, plant maintenance, and state corruption.
In this chart, you can see the different energy sources that Ecuador has, and they sum up to 7,000 megawatts. And we generate 34 terawatt hours each year, but only consume 29 of those terawatt hours. And the government has been developing a plan since 2023 up to 10 years in the future. With this, you will be asking, what is the problem here if we consume less than what we generate? Well, in the months between August and November, we face droughts that reduce the amount of water we have and hence also reduce the amount of energy we can produce. Let's go with the pestle analysis.
Our problem has many areas of knowledge and engineering connected to it, and in order to bring our best solution, it's crucial to understand these aspects. We start with public companies have corruption inside their workings, affecting workers who quit and the projects at hand with either too many money for no change at all or propositions that are never completed. Due to the high rate of assassinations, kidnappings, and assaults on the country by criminal gangs, it is unsafe to have energy shortcuts, especially on the night. Many hydroelectrical plants have suffered from technical failures for construction and operate below capacity. And climate change directly affects natural phenomena and disasters, incrementing damage to energy sources and making the demand higher. Now that we understand what's going on, let's move on to our solution.
Before going to the solution, let me introduce you to the hydroelectric complex Paute. This is where the prototype will take place, and that is because this complex is the one that generates the most amount of electricity in Ecuador. It has 3 dams known as Mazar, Amalusa, and Sopladora, and there's a 4th one known as Cardenillo that's being built. A way to make the most useful energy source on the country, which is hydroelectric, during droughts more efficient is to use a mechanism that returns the water back to the hydroelectric complex for reuse.
The impact our project would have is that it would improve the stability of Ecuador's hydroelectrical energy, it would bring efficient short-term solution until long-term energy plan starts working, the government's long-term energy plan, and supports a more reliable, low-emission energy system. Now, let's see our final prototype.
Here are some images of the prototype we developed. Here is a dam from which the water falls and gets stored into this water storage pool. And this suction chamber pulls the water and puts it into this pressure chamber that has 2 pistons of 2 meters in diameter each, which is enough force plus the gravity of the fall here to make the water go up this pipeline back to the dam. The pipeline will be about 800 meters because that's the height of the hydroelectric complex Paute. And it won't actually be vertical but diagonal because of how the hydroelectric complex is laid. And the energy source that will be powering this mechanism will be a small percentage of what the dam produces in its first fall, which will be less than 1% probably to power this machine.
During this challenge, we have learned to approach a problem by viewing it as a system with different approaches of an effective solution. To implement this idea into reality by using 3D modeling website Tinkercad, and have learned an important issue that is threatening the country with another shortcut, the energetical crisis. Thank you for engaging with our presentation. It has been an honor of mine to work with Alejo for our home country. I hope you can get inspired by the solution or have a little more awareness on issues that are happening throughout the world.